1563, an island disappeared, completely, catastrophically, without warning. An entire mountain, the size of a city, collapsed into the Atlantic Ocean in a single event. The wave it created reached heights that no modern tsunami warning system is designed to handle. Every coastline within range was struck before anyone could react. We know this not from legend, not from mythology, from the rocks. Because the rocks remember everything. What the rocks beneath the Cape Verde Islands remember is something geologists are still trying to explain. One collapse, then another, then another. A repeating pattern of catastrophe driven by something enormous moving beneath the ocean floor. Something that has no fully agreed upon scientific explanation. To this day, 470 kilometers off the coast of West Africa, the Cape Verde Islands rise from water 3 kilometers deep. 10 volcanic islands, rising from the Atlantic like fists from the ocean floor. Peaceful from above, turquoise water, black volcanic beaches, quiet fishing villages. Beneath them is something else entirely. Hidden below that surface, a mountain that vanished into the sea and generated a wave large enough to reach South America. Rocks that record not one ancient mega tsunami, but several. An entire seafloor pushed upward by a force scientists cannot yet fully identify. Underwater landslides the size of small countries. At the bottom of all of it, a question dividing geologists for decades. What is actually powering this place? 8 mysteries. Sitting beneath some of the most beautiful water on Earth. This is what lies beneath the Cape Verde Islands. Fogo, highest point in the Cape Verde archipelago. A stratovolcano rising nearly 3 kilometers above sea level. Still active, still breathing. But Fogo was not always this shape. At some point in the recent geological past, the entire western flank simply ceased to exist. Eroded slowly. No, gone. All at once. In a single catastrophic structural failure. Geologists call it a flank collapse, when an enormous section of volcanic island detaches from the main structure and slides into the ocean simultaneously. Estimates place the volume of material that left Fogo at approximately 160 cubic kilometers. Consider what that means. The entire volume of water in Lake Erie is roughly 480 cubic kilometers. 1/3 of that, but in solid rock, dropped into the Atlantic in a single moment. Replacing it on Fogo is something called the Bordera, a massive ancient caldera scar, an amphitheater of cliffs marking exactly where the mountain once stood. Standing inside it today, you can look at the walls and understand that everything visible was once on the other side of those cliffs. Now, it sits 3 kilometers beneath the ocean surface, 160 cubic kilometers of rock entering the ocean simultaneously, does not disappear quietly. Water responds, violently. What the Atlantic did in response to Fogo's disintegration is the second mystery. Santiago, largest island in the archipelago. In 2014, a Columbia University research team arrived to study its coastal geology. Tsunami evidence was not on their agenda. Finding it was unavoidable. Across the cliffs and slopes of Santiago, at elevations that should never contain ocean material, marine deposits appeared. Sediment layers containing shells, coral fragments, and ocean floor material sitting 170 meters above sea level. 170 meters above the waterline. For ocean material to reach that altitude, the wave carrying it would need to have been staggering in size. Geologist Ricardo Ramalho's team ran the calculations. Their estimate, at minimum, 170 meters of wave height at the point of impact. Possibly greater. For comparison, the 2004 Indian Ocean event, the largest tsunami in recorded human history, reached approximately 30 meters at affected coastlines. What struck Santiago was potentially 6 times that height. 6 times. Dating placed the event at approximately 73,000 years ago, before any human settlement, before any witness, before any written record existed anywhere on Earth. Ramalho's team published in Science Advances in 2015. The scientific community took notice because a wave of that magnitude, generated mid-Atlantic, would not stop at Cape Verde, West Africa, the Caribbean, possibly South America, all within reach. This was one event, one structural failure, one catastrophic wave. Closer examination of the geological record revealed something more troubling. It was not one. Beneath the sediment layers on Santiago sat more sediment layers. Multiple events, stacked, each representing a separate catastrophe, separated by thousands of years. Mapping the underwater terrain surrounding Cape Verde revealed debris fields from collapses across multiple islands, across multiple geological periods. Giant underwater avalanche deposits stretching hundreds of kilometers across the seafloor. Distinct events, different source islands, different centuries, identical outcomes, catastrophic structural failure, massive displacement of water. Waves at heights no modern coastal infrastructure is designed to survive, then silence for millennia, until the cycle repeated. Patterns imply causes. Here, the cause is not any individual island. Whatever has been destabilizing this archipelago, repeatedly, across hundreds of thousands of years, lies beneath all of them simultaneously, rising slowly, pressing upward, through the floor of the Atlantic. Beneath the Cape Verde Islands, the seafloor is wrong, measurably wrong, consistently wrong, undeniably wrong. Oceanic crust in this part of the Atlantic has been drifting away from the mid-Atlantic ridge for approximately 120 to 130 million years. Old crust is cold, dense, and sits low. Standard physics, standard geology. Cape Verde's seafloor sits several hundred meters higher than its age should allow. Something is pushing it upward. Most geologists point to a hotspot, a column of abnormally hot material rising from deep within the mantle, pressing through oceanic crust, generating the volcanic activity that built these islands across millions of years. Where the scientific community fractures is on the source of that heat. A 2020 study in Nature Geoscience analyzed seismic data from directly beneath the islands. Findings indicated a thermal anomaly extending at least 1,000 kilometers down into the mantle, possibly deeper. Context: Earth's mantle spans approximately 2,900 kilometers in total thickness. Whatever is heating Cape Verde from below may extend more than 1/3 of the way through our planet's interior. Nobody fully understands why it is there. Why here, in the middle of the Atlantic, far from any tectonic plate boundary, far from any obvious geological trigger, this column of heat exists, reshaping the surface above it, in ways still becoming visible. Static is the wrong word for these islands. Moving is correct, changing shape, sinking in some places, rising in others, at rates measurable within a human lifetime. Santa Lucia, one of the smaller uninhabited islands, shows ongoing erosion and subsidence, losing material faster than geological processes can replace it. GPS monitoring across the archipelago confirms vertical movement in multiple directions simultaneously, millimeters per year, which sounds negligible until multiplied by thousands of years and then by hundreds of thousands more. What emerges from that multiplication is the slow-motion birth and death of landmasses, erosion from above, internal instability from volcanic processes, subsidence as cooling material contracts over centuries. Occasionally, when internal structure can no longer support the accumulated weight above, catastrophic failure. Fogo's collapse was not an anomaly in the geological record. It was a routine event in the life cycle of a volcanic island on an active hotspot. Scientists studying Cape Verde are no longer asking whether another structural failure will occur. The question is, which island, which flank, at what scale, and what the resulting displacement of water will look like. In 2019, a multi-beam sonar survey of the surrounding seafloor returned data that reframed everything. Scale was what it revealed. Buried beneath Atlantic sediment, invisible to any previous technology, lie landslide deposits of extraordinary dimension. Individual debris fields stretching 50 to 100 kilometers outward from the base of the islands. Material volumes dwarfing anything visible on the surface above. Among the largest mass movement events ever identified on Earth. Sitting silently, thousands of meters below the waterline, covered by centuries of accumulated ocean sediment. Before sonar resolution of this quality existed, 30 years ago, none of this was known. These collapses left no trace visible to us, no record accessible without the technology. We had no idea the islands had this history. We had no idea events at this scale had occurred here. We had no idea what we were sailing over. What the sonar revealed was a question with implications beyond Cape Verde entirely. Across Earth's oceans, 75% of the seafloor remains unmapped at meaningful resolution. How many other deposits like these are down there? How many other events, mass movements, collapses, ancient wave-generating failures, are recorded in sediment we have not yet examined? Darkness, in geology as in history, conceals the most consequential things. Rarely does the scientific community openly admit it does not know something this fundamental. About Cape Verde, they do. Powering this hotspot, the source, the mechanism, the depth, remains genuinely unresolved after decades of dedicated study. Two competing theories have divided researchers for years. First, a deep mantle plume. Superheated material rising from near the boundary between Earth's mantle and outer core, approximately 2,900 kilometers down, traveling upward through solid rock over millions of years until it reaches the base of the oceanic crust, melts it, and drives volcanic activity at the surface. Second, a shallow thermal anomaly. Unusual heat concentrated in the upper mantle only, generated not by a deep connection to the outer core, but by local processes, perhaps ancient tectonic configurations, perhaps plate boundaries that no longer exist. Why does the distinction matter? Deep plume means Cape Verde sits above a window into Earth's deepest interior, a direct connection to processes occurring near the planet's core. Shallow anomaly means something fundamentally different about how heat distributes through the mantle, with implications for models of planetary dynamics worldwide. Neither camp has won. In 2022, a seismic tomography analysis published in Earth and Planetary Science Letters presented evidence favoring deep plume. The same year, a separate team's data suggested the anomaly does not extend deep enough for the plume model to hold. Two peer-reviewed papers. Same underlying dataset. Opposite interpretations. Both published. Both standing. This is not scientific failure. This is science at its most honest, acknowledging the boundary of current knowledge rather than manufacturing consensus where none exists. What remains unknown about Cape Verde's engine exceeds what is known. And what remains unknown about the Atlantic floor surrounding these islands may be the largest unanswered question on this entire list. 106 million square kilometers of ocean. Less than 25% mapped at high resolution. The remaining 80 million square kilometers, seen only in coarse imaging, or not examined at all. Mars has been mapped more thoroughly than the floor of our own ocean. Cape Verde's surrounding seafloor, among the most geologically active zones in the entire Atlantic, falls into the partially examined category. Partially. In the fraction already studied in detail, researchers found mega tsunami deposits, ancient catastrophic landslides, a thermal anomaly extending potentially 1,000 kilometers into Earth's interior. Evidence of repeated island collapses spanning hundreds of thousands of years. All of that in the portion already looked at. Oceanographer Robert Ballard, who located the Titanic wreck, has spent decades pressing for systematic ocean floor mapping. His argument remains consistent. We know more about the surface of the moon than we know about the bottom of our own ocean. First stated in 1985. Still accurate today. Beneath the unexamined Atlantic, what other ancient collapses sit recorded in sediment? What other hotspots are building future islands in water currently too deep to detect? What other wave-generating failures has this ocean witnessed across 4 billion years? Events with no human witness, no written record, no monument. Unknown. Because unexamined. This is not a question about Cape Verde specifically. It is a question about a species that has spent centuries mapping the stars and decades exploring other planets, while less than a quarter of its own ocean floor has been looked at carefully. What lies in the remaining 3/4 is the genuine frontier, and it is directly beneath us. 8 mysteries. Beneath some of the most peaceful-looking water on Earth. A mountain gone. Dropped into the Atlantic in a single geological moment, generating a wave 6 times the height of the largest tsunami in recorded history. Clifftop rocks at 170 meters elevation, remembering what the ocean did 73,000 years ago. Repeated collapses, not one event, not an anomaly, but a pattern, driven by something moving beneath all these islands at once. A seafloor sitting hundreds of meters above where physics says it should be, pushed upward by heat whose source 2 peer-reviewed papers in the same year could not agree on. Land masses visibly in motion, some rising, some sinking, in the slow geological rhythm of birth and disappearance. Landslide deposits the size of countries buried beneath kilometers of ocean, unknown to science until 30 years ago. A hotspot debate unresolved after decades of dedicated research, and 80 million square kilometers of seafloor not yet examined carefully. From the surface, Cape Verde is peaceful. Clear water, black sand beaches, fishing boats moving between islands in the morning light. Beneath them, at depths no human has reached, under pressures no current technology can easily sustain, the planet is doing what it has always done. Moving, heating, building, dismantling, without schedule, without announcement, without concern for what sits above. Rocks record all of it, every collapse, every wave, every shift of the mantle below. Only now are we developing the tools to read what they have written. Cape Verde is not a geological puzzle. It is a reminder. Earth is unfinished, unstable in ways we are still discovering, far less understood than we tend to assume. Most of us think of this planet as something fixed, mapped, categorized, known. 75% of its ocean floor says otherwise. You have been here for 200,000 years. This planet has been doing this for 4.5 billion, and you have looked carefully at less than a quarter of it. Keep looking, because what you find will not confirm what you thought you knew. It will expand it. If this is the kind of story you want to keep following, the kind that goes deeper than the surface, Enigma Science exists for exactly this reason. Discover the world with us. Subscribe. Because what lies beneath the next place we visit is already there, already moving, already waiting.